Hey, Matt Matherson here with Matt Madness. Thank you so much for joining us and being a part of the program today. You know, my wife and I, we both really do appreciate it. Okay, well, we're continuing on our discussion with the L'Hopital rule, limits and derivatives, and how those two things work in conjunction with each other so that we can solve for those gnarly rational functions that just don't want to cooperate under certain circumstances, right? So let's look at a few more of those certain circumstances, if I can say that properly today. Well, the last episode we said that we can utilize the L'Hopital rule when we've got infinity over infinity. Doesn't matter if it's plus, minus, that's fine. But today we are going to be dealing with something when it's undefined. And by undefined, we just mean it's being divided by zero, correct? And that's what's going on here today. We've got zero being divided by zero. So our zero as the divisor is undefined. So if we can get into this format, then we are allowed to use L'Hopital. And this is the limit that we're being tasked with to solve for today's episode. We've got the limit here as x approaches 1, and our limit here that we're asked to find is the ex minus e, and that's being divided by our natural log of x. Okay, well, we know we're looking for the 0 over the 0 here, yes? Well, how do we know if this is the case? I mean, just by looking at this, how do we know if we're in a situation where it's undefined? Well, we can go ahead and plug and go as we did for the last episode, yes? Yes. All right, well, we know that x is approaching 1, so we know that this e being raised to the x, we know that x value is 1, isn't it? So e raised to the 1 is, yeah, it's just e, isn't it? So let's go ahead and make this our e. Well, what do we have now? Well, we've got e minus e here in the numerator, don't we? And that's going to give us a value of 0 for the numerator. Yes, just all I did was say e minus e. That gives us the 0. Well, what about the natural log here in the denominator of x? How does that work? Well, again, x is approaching 1, yes, and ln of x, if I plug in 1 here, what does that give us? Well, ln of x, if I plug in 1, gives us, yeah, you probably guessed it, it's going to give us a 0, isn't it? Okay, so it looks like we are in a situation where we can use L'Hopital's rule because we are in a case of something is being divided by 0, which makes it undefined, and this is the case here as well. So take a good look at that. All right, well, since we know that we are allowed to use the L'Hopital's rule here, what are we going to do? Yep, I'm going to go ahead and acknowledge that's what we're going to be doing, and then we're going to do like we have done in every other case. We are going to take the derivative of this mess in order to find the limit of a new mess. And you know, if you've been here for the episode previously, you know it's just a bunch of messes that we accumulate and we find the limits of. All right, well, now that I've got that out of the way, let's just go ahead and acknowledge that we will be taking the limit as x approaches 1. And we do know that we're in the situation that this is a rational function, meaning it's a fraction. So let's just go ahead and take the derivative of e being raised to the x, which we've said several thousand times already is just what? E to the x, it is. Well, what about this minus e over here? Well, there's no x, so what's going on with it? Well, it's just a constant. So that goes bye-bye, sayonara. Okay, wonderful. We've got the numerator taken care of. Well, what about the denominator here? What is the derivative of ln of x? This is one, if you don't know it, you're just going to want to put this in the memory bank. You don't want to have to prove this every time you use it. It's just 1 over x is the derivative of 1 over x. I actually may do an episode later proving that's the case, but I'm not going to do that today. Fine. Okay, well, what are we dealing with now? Well, we've got a complex fraction. How do we deal with complex fractions? Same way we deal with any other fraction that we've done before, haven't we? Right? Okay, well, with just plug and go here, we've got e being raised to the 1 here because we know I didn't put that here, but x is approaching 1, and e being raised to the x, in this case, is 1. So we've got e being raised to the 1 is just e. Over, if I plug in the 1 here for the x, because again, x is approaching 1, and if I plug in x here, that's going to give us a 1, isn't it? And then 1 divided by 1 is just 1, isn't it? Well, what happens if I take e and divide that by 1? Well, you got it. It becomes simply e. Well, L'Hopital rule saves us again. All of this done in just a few seconds and a few steps to provide us with the limit of e. Well, that's all the time we have for here on Math Madness. I am Matt Matherson. My wife and I will see you anon.